Hey everybody, today I'm going to be going over data compression in Java, more specifically Zstd and how it can be applied to Minecraft development. So Zstd is made by Facebook. It was released in 2016 and it was specifically made to replace older compression software such as Zlib because they were beginning to show their age and not being as efficient as they could be. Zstd is a better solution than Zlib for pretty much all use cases. So it compresses better, it compresses faster, and it also decompresses faster. It decompresses way faster, which we'll see on the benchmark slide. So here's an example of Zstd's efficiency. Speed is by far its strongest asset. Some compression software might compress better than Zstd, but they're definitely going to be compressing and decompressing slower than it. You can see the benchmarks here. Here's Zstd, the normal version at the top. It has better ratio than Zlib does, and it also has way faster compression and over 4 times decompression speed. Minecraft still uses Zlib, even though Zlib is very old. Zlib was released in 1995 and Zstd was released in 2016. So you'll be able to get a lot of use out of Zstd instead of Zlib. So how can you use compression in Minecraft development? Well, if you're storing long strings such as encoded objects and user stats, you're able to compress it before you put it into a database, which will allow you to store a lot more of those objects. If you want some extra performance, you should probably cache the data before and after runtime. That way you're not decompressing and compressing very frequently and not using unnecessary CPU time. By far the most important part of Zstd is its ability to decrease the amount of data you're transferring from the end user to the server, which is definitely going to help in larger applications such as large servers with many hundreds of players on them. It's definitely going to decrease the size of the footprint of your application. Compressing and decompressing does use CPU time, which is one con to compressing and decompressing data, but outside of runtime it's far better because you're not going to be using as much space. Okay, here I am in IntelliJ, and I've got a dependency to a Zstd Java library, which will be in the description of the video. It is a Maven dependency. I've already got it installed, and then let's head to the main file. So I've already preloaded a very large string here. Let's see exactly how big this string is. So let's get the bytes, and then length, and then run it. Alright, as we can see, the byte is 12,236 bytes long. That's pretty long for a single string. So let's see if Zstd can help us out to compress this string. So we're going to make a primitive array called compressed is equal to, we're going to call Zstd.compress, and then we got to provide it a byte stream. So we're going to say string.getBytes, semicolon, and now we're going to see what the new size of this byte array is. Okay, as we can see, the original string was 12,236 bytes long, and the second string, the compressed string, is 3,375 bytes long. That's a pretty impressive decrease, around 4 times decrease. So now we're going to decompress the compressed string back into the original string up here. So we're going to do a little more than just what we did for compressing. We need to pass the length of the byte array right here, string.getBytes.length, on top of the compressed byte array right here. So we're going to say z or new string Zstd.decompress compressed and string.getBytes.length. Okay, now let's see what happens. Okay, as you can see, it printed out the original string. Now, how can we be sure that this is a lossless algorithm? We need to, most of the time, get the same data out as we put in. So let's check that that string that we have up here is the same as the one that we decompress. So if string dot equals, and we're just gonna move this over here. Okay, let's run it. Alright, apparently it's the same. So the string up here that we had preloaded into the program is the same as the one that we compressed from this string and then decompressed. So that's a pretty impressive display of the powers of Zstd and how you could use it for your purposes. Links and resources will be in the description.